You had the most vivid dream of your life. You were there. You felt everything. And within 10 minutes of waking up, it was gone. Vanished. Like it never existed. This isn't a glitch in your brain. It's a feature. And the reason why might disturb you. Every single night, you spend about 2 hours dreaming. That's roughly 6 years of your life spent in dream worlds. Yet most people can barely recall a fragment. Maybe a face. A feeling. Sometimes nothing at all. For decades, scientists assumed we simply didn't pay attention to our dreams. That they faded like any unimportant memory. But that explanation never made sense. Because dreams aren't boring. They're often intense, emotional, sometimes terrifying. These are exactly the kinds of experiences your brain is designed to remember. So why don't you? The answer lies in a chemical switch your brain flips every time you enter REM sleep. A switch that essentially turns off your ability to form new memories. And when researchers discovered why this switch exists, they uncovered something far stranger than anyone expected. To understand why you forget your dreams, you need to understand one molecule. Norepinephrine. It's a neurotransmitter that does many things, but one of its most critical jobs is helping your brain stamp experiences into long-term memory. When something important happens while you're awake, norepinephrine floods specific brain regions. It tells your hippocampus, save this. The more norepinephrine, the stronger the memory. This is why you remember where you were during shocking news. Why emotional experiences burn into your mind. Norepinephrine acts like a highlighter for your brain. But here's what makes dreams different. During REM sleep, your brain does something radical. It almost completely stops producing norepinephrine. The levels drop to near zero. Your memory highlighter runs out of ink precisely when your dreams are most vivid. This isn't an accident. It's not a resource-saving measure. Brain scans show that during REM sleep, your brain is almost as active as when you're awake. Sometimes more active. It has plenty of energy to produce norepinephrine. It simply chooses not to. The question is why? Why would evolution design a brain that experiences something intensely but refuses to record it? In 2019, researchers in Japan discovered something remarkable. They found specific neurons in the hypothalamus that actively suppress memory formation during REM sleep. These cells produce a hormone called MCH, melanin concentrating hormone. When scientists blocked these neurons in mice, something unprecedented happened. The mice started remembering their dreams. Or more precisely, they started retaining information presented during REM sleep at much higher rates. Their brains were suddenly recording experiences that would normally vanish. This confirmed what neuroscientists had suspected. Dream forgetting isn't passive. Your brain is actively working to erase these experiences. It's using dedicated neural machinery specifically designed to prevent dream memories from forming. But this discovery raised an even bigger question. What's so dangerous about remembering dreams that evolution built a dedicated system to delete them? The answer might be the most unsettling part of this entire story. And it has everything to do with a problem your brain cannot afford to have. Imagine waking up tomorrow unable to distinguish between things that actually happened and things you merely dreamed. Your brain holding dream experiences with the same weight as real ones. You remember a conversation that never occurred. An event that never took place. A person who doesn't exist. This isn't hypothetical. It's called source confusion. And it's one of the most destabilizing things that can happen to a human mind. Your brain's entire model of reality depends on one crucial ability, separating real experiences from imagined ones. When this ability breaks down, the consequences are severe. Certain psychiatric conditions are characterized precisely by this confusion between internal experiences and external reality. Now consider what dreams actually are. They're vivid, emotionally charged, first-person experiences. They come complete with sensory details. Faces. Places. Conversations. They feel real because, to your dreaming brain, they are real. The same neural circuits that process actual experiences are firing. If your brain stored these experiences as normal memories, you'd wake up every morning with hours of convincing false memories competing with real ones. After years of this, how would you know what actually happened in your life? This is where the evolutionary theory of dream amnesia becomes compelling. Your brain didn't evolve to remember everything. It evolved to build an accurate model of reality that helps you survive. False memories are dangerous. They corrupt your understanding of the world. They could make you trust someone untrustworthy because you dreamed they helped you. They could make you fear something harmless because you dreamed it hurt you. From evolution's perspective, a brain that confuses dreams with reality is a brain that makes deadly mistakes. So perhaps dream amnesia isn't a bug. It's a survival mechanism. A nightly garbage collection that clears out experiences your brain knows are fictional before they can contaminate your operating memory. The norepinephrine shutdown starts to make sense. Your brain deliberately disables memory consolidation during REM not because dreams are unimportant, but because they're too important to remember. They serve their purpose during sleep. Processing emotions, consolidating skills, simulating threats. But once morning comes, their job is done. And letting them linger would only cause problems. But this raises an uncomfortable question. If your brain is this aggressive about deleting dreams, what else might it be filtering out? Some people do remember their dreams. Vividly. Consistently. Are their brains broken? Not exactly. Dream recall varies dramatically between individuals. Some people remember dreams almost every night. Others go years without recalling a single one. The difference appears to be related to brain activity during the transition between sleep and waking. People with high dream recall show more activity in the temporoparietal junction, a brain region involved in attention and memory encoding. They also tend to wake more frequently during the night, giving them more opportunities to catch dreams before they dissolve. But here's what's interesting. Even excellent dream recallers are only capturing a tiny fraction of their dreams. Studies where participants are woken repeatedly throughout the night show that people dream far more than they ever remember. The best recallers are simply catching more scraps. There's also evidence that actively trying to remember dreams can increase recall. Keeping a dream journal. Setting intention before sleep. These practices seem to partially override the forgetting mechanisms. Your brain can learn to treat dream memories as worth keeping.